so the second word question we're going to look at is the following. So a company models its annual profits using the function P of X, and it's then stated where P of X represents, where P represents profits and X is the number of units sold. It asks how many units need to be sold for a profit of this number. Okay, so we're actually given a fair amount of information. It's kind of nice too that they actually gave us an equation. That helps a little bit too. So let's look at what we're given. We're obviously given our formula. We're given the fact that P represents profit and X is the number of units sold. Okay, so under the given, that's what we're going to put. We have units sold, P is profit, and profit needs to be 167,700. Now, what's required of us is they want to know how many units for this amount of profit. So that's what's required of us. So we need to know that. And for some reason, it doesn't want to come. There we go. So how many units X when P of X equals our dollar amount? Okay, now for analysis, what we're going to do is we're not going to jump right in and do the quadratic formula or anything like that. We're going to take the information we know. So we have our formula P of X, but we also know from what's required that we want our profit to be this amount of money. So we're going to replace in our formula the PX with this number. So that's the first step that we're going to do. So we will get, seems it wants to come and, sorry, it just doesn't want to go to where I want it to go. Okay, so our P of X in this case, we said was 167,700. And that is to equal our x squared plus 20x minus 300. Now, because we're solving for x, we need to have one side equal to 0. So what we're going to do is we're going to subtract this dollar amount from both sides in order to end up with 0. So we have x squared plus 20x. And when I subtract, I end up with a larger number. So we end up with negative $168,000. Okay, so now we have this, and now we can solve for x. We have two different ways to solve for x. We can factor, which I don't think we can factor this. We could do the other way where we complete the square and then solve for x that way. Or, because what we're working on is quadratic formula, we're going to start with the quadratic formula. So let's take a look at our quadratic formula. Here it is for us. And what we're going to do is we're going to go up to our equation and figure out what our A, B, and C are for this question. So the first thing, since we get down to here, and as I said, often I like doing this. So I have A is 1, B is 20. Make sure you take the signs with you because it will make a big difference if you have the wrong sign. And C is negative 168. Okay, so now it's just a matter of substituting it into our formula. So we end up with a negative 20 plus or minus the square root of 20 squared minus 4 times our 1 times our negative 16800. Okay, remember that's all underneath the square root. And we have 2 over 2 times 1. Okay, so now it's just a matter of taking our calculator and actually calculating this. So we end up with negative 20 plus or minus, and I'm going to assume that you can actually use your calculator and calculate that in one step, which would be, well, maybe not. So we have 400 plus 672,000, and that all over 2. And when we actually do that, we end up with negative 20 plus or minus, and I'm going to take the square root, so 820 all over 2. So we have our two roots located here. We have 400, and we also, when we take the negative 20 minus 820, so we have negative 840 divided by 2, we have negative 420. Now, when I look at both of these roots, the thing I have to be aware of is I'm talking about units produced. So it doesn't make sense to have a negative number. So this number is inadmissible, okay, because we cannot have a negative number. And so you do have to say that it's not allowed, inadmissible. You just can't just ignore it completely. Okay, so that number is inadmissible. So now what we need to do is we just need to have our statement. So we have therefore, and I'm actually going to type it because it is neater when I do type it. And we'll do with this. We have they need to sell 400 units. Okay, so there's that question. And we're going to do one more question. Okay, the next one. Next one's a little bit different. You can see they didn't, just by looking at it, you can see that there's no formula given here. So we're going to have to do a little bit more work. So we have an open top box is made by cutting 3-inch squares from each corner of a square piece of cardboard, and then folding up the flaps. The volume of the box is to be 1,083 cubic inches. Find the dimensions of the original piece of cardboard. Okay, so let's take a look at what we're given here. We're actually, again, given some information, but how well it will be received is something else. So we know that we have volume is given to us. So we have volume equals this, and it's inches cubed. And we also have information about this box. Now I'm just going to put my volume over a piece here. So I know I have a box, and so we are going to just draw a box. And that's one nice thing about the software. Okay, so we have a box. They tell us that there's 3-inch squares taken out of it. So we have this is taken away in each corner. Okay, so a question like this, please make sure you draw a picture, because even if you can't get anything else, the picture tells an awful lot. So we have this box, and we know that those corners have been cut out, and we know that each corner is 3 inches. So we're going to put our 3 inches here, right, and 3 inches here. There's 3 inches everywhere. Okay, and we know that they're going to fold it up in those places to make an open-ended box. And so this dotted part in here would be the bottom of the box. Now, what are we required? Well, they tell us they want the dimensions of the original square, okay, because they started with a square. So we want the dimensions, and I think I'm going to type this one again because it is actually faster. Dimensions of original square. You can see by having it done in the grass kind of box that we have here that it is much easier to get some more information. So let's take a look at what don't we know. Well, let's take this box. Here it is. Oops, here it is. Okay, and well, actually, I think maybe I will clone the whole thing because that might be to our benefit. As soon as I get it, come on, clone, bring it down here. Okay, so what they're after here is they're after the length from the top to the bottom. Okay, so that's the dimensions they want, and the same thing here from the top to over here. So what we're going to do is we'll call that our x. So those are our x's because we don't know what those equal. So let's take a look at then what we're talking about with our box. So if we actually draw it, and I'll attempt to draw it. So there's kind of our drawing of it. So from this, we know that we end up with a box like this. Okay, and so if we look at this, this is like an X. Okay, so the length X. And what we've done is we've taken away a 3 and another 3. So we've taken away 6. The same thing is here. I have X and I'm taking away 3 and 3. So again, I'm taking away 6. Now, the third dimension, this dimension here, is not x minus 6. It's actually this when it's folded up. So it's actually 3. Now, the other thing that I know is volume equals length times width times height. So in this case, I would have 3 and it's being multiplied by x minus 6 squared, right? Because the width and the height, width and length are the same. Okay, so that's supposed to be a 6, by the way. Okay, so let's take a look at this. So we know this is very similar to our last question. We know the volume. Okay, the volume they tell us needs to be this. So we're going to replace the volume with that and see what we end up with. I think we'll have something very similar to what we did before. Okay, so let's do that. Okay, so you can see that I put down the volume and I actually took our volume formula, what we have so far, and put it together. So just like the last question, what we need to do is we need to get that to the other side. But you also can see that we're going to need to expand this square. So I'm going to stop. Well, no, actually, I'm not going to stop. Let's just go ahead and expand it. So we have 1083 and we would have 3, and remember those two brackets are identical, so it's this squared, which would be x squared, this times 2, so negative 12x, and a 36. Okay, now we're going to expand the 3 into the bracket, so we have our number on the left hand side again, and we end up with 3x squared minus 36x, and then we end up with 108. And now what we're going to do is we're going to subtract both sides by this, so we end up with 0 equals 3x squared minus 36x minus 975. Now what we need to do with that is now we can use the quadratic formula. Now you can see that each one of those terms is divisible by 3, so we could actually divide everything by 3 to make our numbers a little bit smaller. Now the reason we can divide by 3 is we have 0 on this side. Okay, otherwise you can't do that, so we end up with x squared minus 12x minus 325. Now, just like the previous example, we take the quadratic formula, substitute our numbers in. Sorry, I'm going kind of fast here. And voila, we get our 2 roots. Again, we end up with a -1 and a +1. We throw away our -1, so our answer is 25. So we know the dimensions of the page was 25 by 25. So a few questions for you to work on, debate with this from your textbook are the following ones. And we'll have another lesson again using different kind of skills.